Okay folks, this will be a very short video and we're going to solve this matrix equation here. We solved a similar matrix equation up above, but we did so with using the actual column vectors and coefficient matrices and its inverse, and here we're going to do it more abstractly. By the way, this should be a bold X that'll be fixed in your handout. So I am a stickler for this. I'll go ahead and tell you now, I always put this question on an exam, and I'm a stickler for the way you do it. And the reason why is because we've got to learn how to treat these matrices differently from how we treat numbers. And the algebra that we do with matrices is different from the algebra that we're able to do with numbers. So the first thing we need to do is we need to make the assumption that A is invertible. If A is an invertible, then none of what I'm about to do is going to work. So the next thing I'm going to do is let's take that equation, matrix A times X is equal to, we'll leave the parentheses off right now, is equal to B. And by the way, folks, I am using the same notation here. So just so you know, X is thought of, it doesn't have to be for this to be true, but think of it as a variable vector. And B is a constant vector, and A, as we said, is an invertible matrix. And I'm assuming all these dimensions align, so let's not worry about that. So this is what I need to see from you when you're asked to solve this problem. I want to see you take a line in which you multiply both sides of this matrix equation by A inverse. And it is key that it be multiplication on the left. I put the A inverse to the left of AX. Now, it's not so, the reason why I do that is not because of what's on the right hand side there. It's because on the left I want to eventually group the A inverse and the A together. And then as a consequence I have to put the A inverse B on the left hand side, and of course that also works with the matrix multiplication, so it's a good thing we did it. So the next step is using the associative property of matrix multiplication, where I have rewritten the grouping symbols on the left hand side and kept everything else the same. So I've rewritten the grouping symbols, so rather than thinking of multiplying A inverse to this result, we're going to take the product of A inverse and A and multiply it to this column vector X. And this part, please folks, I do not want you to shortcut. What happens when you multiply A inverse times A? You get the appropriately sized n by n identity matrix. And then what is the n by n identity matrix when multiplied by an n by 1 column vector? It will just be that same n by 1 column vector by the properties we've already discussed of that n by n identity matrix. And so folks, what we've done is the algebraic equivalent of solving a very simple equation, but it was more complicated in matrix land. And again, I am going to be a stickler for showing these intermediate steps. There's not an intermediate step in here that you could shortcut in this class. Let me know if you have any questions.